Okay, so I'm going to look at the partial differentiation question from the sample paper that I put up in web courses, and you can print it off or have a look at it on your computer screen or whatever you need to do. So I just go down here to question 1. So I have z equals this expression here, find the x derivative, find the y of the x derivative, find the second x derivative, or in other words, the x of the x derivative, and then the second y derivative. Right, so I'll just sort of do the first one first, and I need, I'll do del z del x first. Right, number 1. Okay, so I'll just retake the expression for z so that I can have it right above me. Cubed plus 3x squared y minus 11y. Right, so I want to differentiate that with respect to x. That means if there's any y, if there's any term that has an x in it, fine. There's going to be I'm going to have to differentiate it. Any term that does not have an x in it, that's going to disappear in the for the x derivative. Right, so you can take your time with it, and I'll kind of put it like this. I'll say, right, so the x derivative of z, or the x partial derivative, I keep saying I keep missing the word partial, but sure doesn't matter. For right, so I'll say, right, there's an x there, so that has to be differentiated, and I'll just open up a bracket and I'll go back in and fill it later. For this guy here, I say, right, there is no x there, so that's just a plus 0. There is going to be a x derivative here, and I'll come back later and fill it into the bracket. And then for this guy, there is no x there, and that minus 11y, so that just goes to 0. Right, so I'll go back now and fill the bracket. So the derivative of x squared, that's 2x. Nothing there. The derivative of x squared here is another 2x again, and that's 0. So I'll just kind of finish it off and kind of clean up my final answer. So my answer is del z del x equals 5 by 2 is a 10x, 0, I won't write it again, plus 6xy, and then the other 0 at the end, and that's my x derivative. Right, for the next one, that means the y of the x derivative. I read it from left to right. I say the y of the x derivative. I read the bottom from the left to right. So I need to, for my y derivative, for my x derivative there, I now find the y derivative of that. Right, so I'm going to start this down here. Part 2. And I'll just keep that. I have the x derivative right above me, and I need to just find the y derivative of that there. Right, so I'll put it like this. Now look at the way this goes, is because when you're talking about, you have to, the derivative of a derivative, that's a second derivative, so this is why I say del squared z, and then the y derivative of the x derivative. Right, so I'm looking above me and I'm saying, right, well, there's no x, there is no y, I'm differentiating with respect to y this time. There's no y there, so that's a 0. There's a y there, so that something will have to happen here. So I ignore all the other terms, 6 and the x's, any numbers in x's, ignore them, and fill that bracket in a minute. Right, well, there's nothing else left to worry about, so I'm about to fill that in. I have to differentiate that y. With respect to y, the derivative of y on its own is just a 1. There it goes. Right, I'll just kind of finish it up and clean that up there just to wrap it up. Del squared z del y del x equals 6x by 1 is just a 6x. Right, part 3, what do I need here? I need del squared z del x squared, that's the x derivative of the x derivative, or the second x derivative, or differentiate z with respect to x twice. Okay, well, I already did it once, There it is in the this blue guy here. So I can just differentiate that with respect to x again to get del squared z del x squared. So what I'll do, I'll just take it. You can rewrite it if you were working on the sheet. You could retake this down with you. I'm just going to copy it and paste it down here. So we have part 3. There's my fella there. Okay, so I'm going to differentiate that now with respect to x again to get the second x derivative, which the notation for it is del squared z del x squared. Right, again, do the usual business. Does something have to happen here? Yeah, and something has to happen here as well. They're both terms of an x in it, so I have something to worry about each time. Right, so a 10 by, and I'll fill it in later, plus a 6. Do something with that x now in a minute, and nothing happens. The numbers and the y's this time again. Right, derivative of x on its own, that's just a 1. That x there, the derivative of x again on its own is a 1. And just say to yourself, I'll clean this up. Del squared z del x squared equals 10 by 1 is just 10, 6 by 1 is 6, and the y stays there. Okay, is that not another part left? What does that mean? That means the y derivative of the y derivative, or the second y derivative. It means differentiate z with respect to y twice. So the problem is we didn't even do it once yet. None of our questions needed the y derivative first. So before we even find the second y derivative, we better find the first y derivative. So I need to start again and differentiate this expression of z with respect to y to at least get the first y derivative. Okay, part 4. So again, you won't. You take it back. If you were working on pen and paper, you would rewrite z so that you can have it's right above you, so that you can kind of look at it and differentiate with respect to y. Right. So the first y derivative is del z del y, and again, I'll just kind of look at that and say, right. There's no y there. There is a y there, and there's a y there again. Right, so when I'm differentiating the first term, there is nothing. There's no y there, so it's a 0. The next time, well, ignore everything surrounding the y, and put a bracket for the y term, whether it's y cubed or whatever it is. And we'll fill it in now in a minute. Plus 3x squared. There's a y there. I'll go back and fill it in now in a second. And a minus 11. Something has to happen that fella there as well. Right, y cubed, back here again, y cubed, that becomes 3y squared when I differentiate with respect to y. The y on its own becomes a 1. Y on its own again becomes a 1. Right, and just the next line will just involve me cleaning that up. Del z. Now I'm not done yet because I still have to find that second y derivative. Right, minus 4 by 3, that's a minus 12 y squared plus 3x squared there, minus 11 by 1 is just minus 11. Right, now I'm ready to find what I wanted in the first place. The second y derivative, or in other words, the y derivative of the y derivative. So it's called del squared z del y squared. Again, there'll be something will happen there. That's gone, and that's gone. There is no y in that term, and there's no y in that term, and there's no y there either. So and when I take the y derivative, then both of those guys will disappear. Right. So everything else stays, and something happens. The y. I'll come back later and fill it in. 0 there plus another 0 there, and you don't have to. If you want to jump right to the final answer, that's fine. But I just said, sure, I'll take my time with it. Okay, y squared. What's going to happen? That becomes 2y when I differentiate it. Right? You have the differentiation done now. You're just sort of cleaning up your answer. That's minus 24y. Okay, and then wrap it up then. Right, so that was part A, and you can see from the sample papers that it's just kind of the same each time. It's just a mixture of find all the mixes, just a couple of different mixtures of partial derivatives. Right, for part B then, it's slightly different. I want the x and the y derivative, of these expressions here each time. So now that what you're being tested on here is, do you know the product, quotient, and chain rule? So they could come up in any order. It just happens to be. I'll take this over now. We'll just sort of see, can we at least identify what we need to do in each of those questions before we can go to get kind of attack them. Right. Okay. So, well, for this guy here, if I say number one, there's a big clue there, and the big clue is that there's a fraction. It's really, you've no choice in the matter. This must be the quotient rule. For the second one, again, another big tip would be two brackets beside each other. If you want to put it like this, one thing by another thing, or one expression of x and y multiplied by another expression of x and y. For that guy, that must be the product rule. Product is because product's a big word for multiplication, or the product rule. Okay, this guy here then, the third guy, I mean, I don't know what, we kind of try to drill this into in class, how to recognize when you need to use the chain rule. I use the chain rule when I have one of the tables, one of the functions from the logs tables. It could be e to the box. I'm going to kind of draw over. I'll rub these out now in a second, but if you want to take, I kind of put these in another little sample guide. I could have e to the box, sine of box, cos of box, ln of box, or box up to a power. Right. Those are the main 5 cases where you need to use the chain rule. But what you'll ask, what do you mean by box? I mean, if you have anything other than a simple x, if you have an x in that box each time, you don't have any problem because they are directly in the logs tables. That's e to the x stays as e to the x, sine becomes cos, cos of x is sine of x, ln of x is all of that business. You can read the logs tables yourself. If there's anything other than just that simple x in that box, you need the chain rule. So the way the chain rule goes for these 5 functions is you sort of pretend that the box is an x and write down what the logs table says about e to the box. If you pretended the box was x, you would say, right, well, what the logs table says about e to the box is that it stays as e to the box. What the logs table says about sine of box, now it seems completely stupid what I'm saying here, but I'm pretending that box is x. This is the first step of the chain rule. Pretend that box of x. Sine of box goes to cos of box. Right, that's on logs tables. Cos goes to minus sine of box. Ln of box goes to 1 over the box. And box to the power means you take the power down and you leave the box alone, take 1 off the power. Power minus 1. But that's not all in the chain rule. As soon as you do that, in whatever function you were given, you can't pretend the box was x forever. You have to deal with the box eventually. And the chain rule says you deal with the box straight away afterwards. You ignore it first and you deal with it later. Or ignore the box, deal with it later. Or I used to say in class, ignore the inside, deal with it later. But maybe box was a better way of saying it. So you differentiate. So I'll put it like this, deriv, or deriv of box. You put it right out here in a bracket later on. So if there's the sine of box, where it's not just a simple x in that box, something could be as innocent as a 2x, or it could be as it could be a big long expression like an x squared minus y cubed. Anything other than an x needs the chain rule. So sine of box goes to cos of box, and then you differentiate the box out here later. Deriv of box. Straight away in a bracket right afterwards. Cos of box, the derivative of that is minus sine of box by the derivative of the box. Ln of box, that goes to 1 over box by the derivative of the box. And then finally, box to the power, you ignore the box, take the power down, take 1 off it, then straight away afterwards differentiate the box over here. Derivative of box. Sorry for the bad writing, but I think you know what I mean. Okay, so what do we have up here? We have the ln of box, basically. So when I differentiate, that's going to be the chain rule, and it's going to go to, when I differentiate, 1 over the box by the derivative of the box. Now it's better if I just maybe just jump to it and not write that. I'll say, right, 1 over the box is x squared minus y cubed by the derivative of the box. It depends now. We'll wait till we get the question. But if it's with x, it'll be 2x. If it's with y, it's minus 3y squared. But I just wanted to get, can we at least identify what we need to do here for each of those parts? Right, we can. Right, okay, so I'll take all that back away now again, and we'll start up the question parts. Now this will only go back so far. I might just take the whole question down again, copy that. There we go. Right. And all that business there. Okay, so part 1, I have number 1, we said we needed to use the quotient rule there. And I put that in the guide that you can learn the maths, but I think maybe it's just better to learn the English if you want to. And I said an English rhyme goes like, the English rhyme of how to do the quotient rule is bottom by derivative of top minus top by derivative of bottom all over bottom squared. So that's what I'm going to do. I'm going to say, right, I'm differentiating with respect to x first. So del z del x is, and if you want to add the words brackets, even think of, there's a bracket, put all of that top term there in a bracket and all the bottom in a bracket. Bottom, it has to start with the bottom though. Bottom by derivative of top. Right, so the bottom in a bracket by the derivative of top minus top bracket by derivative of bottom all over the bottom squared. So I'm writing that first. I'll leave enough space there so I can get in each. There's only 2 terms each time. I'm sure I'll fit them into those there. Okay, right. So I've that scrabbled out now, but anyway, I can't have the 2. There's a little 2 there that I've scrabbled out. Okay, so just 2 seconds. Let me get rid of those brackets there and do that again. Okay, right. Bottom by derivative of top minus top by derivative of bottom all over the bottom squared. Right, so the bottom, don't do anything with it, just put it in. There's the bottom, x plus 2y squared by the derivative of the top with respect to x. So you can make a big deal about it, or just hopefully after a bit of practice you're used to it at this stage. I don't need to do, you can do your plus 0 business in your brackets, but I'm just going to look at that there and say, well, that's gone when I differentiate with respect to x there. I'm just left with, I only have to worry about that term, and I'm left with a 2 when I differentiate that. So that's just going to go straight into my bracket when I say bottom by derivative of top. There's the derivative of the top. Minus the top. There's the top. Don't touch him this time. By the derivative of the bottom. There's the bottom. Respect to x, he goes, so I'm only left with him. Derivative of x on its own is a 1. So I'm just left with the 1 there. Okay. All over the bottom squared. So that means just put the bottom in and don't do anything with it. X plus 2y squared. And leave it at that there. Right, but I want the y derivative also, so it's going to be pretty much the same thing. I'll just take that screen down a little bit. Right, del z del y. So I'm just starting the whole thing all over again, but when I say derivative of top and derivative of bottom, I mean with respect to y this time. So in a way, there's very little change from your previous answer. Still bottom by derivative of top minus top by derivative of bottom all over the bottom squared. Okay, so the bottom is still x plus 2y squared by the derivative of the top with respect to y this time. So I'm going to get a, there's the top again, bottom by derivative of the top, no y there, I'm just left with a minus 3. 2 seconds. Minus 3. Minus the top by the derivative of the bottom, 2x minus 3y by the derivative of the bottom. So looking at the bottom there, no y that time, so there is a y that for here, and I'll say it's going to be 4y. I'm going to be left with 4y when I differentiate that, and there it goes in that bracket, all over the bottom squared again, x plus 2y squared. So look at how these guys don't change. The only thing that changed between the 2 derivatives were the blue, purple and blue expressions in those second brackets. Right, okay, so over to part 2. So we kind of argued earlier that we need the bracket by bracket, it must be the product rule. Again, you can learn your UDV business, your U and your V business, but I think maybe the English at this stage, the English way of saying it'll come, maybe that'll be better of way to get through the question. The first by the derivative of the second plus the second by the derivative of the first. Right, so I'm just going to take that down there. Or in other words, if you want to add the words brackets after the word first and second, the first bracket by the derivative of the second bracket plus the second bracket by the derivative of the first bracket. You know, if you want to remember that saying like you remember the minus b formula, sure, that'll come in, that'll get you through the question. Right, so when I say first by second, I mean there's the first, and there is the second over there, the second bracket. Right, so I'll fill out my I'll kind of write up my brackets first. So I'm doing it with respect to x first. So it's the first bracket by the derivative of the second bracket plus the second bracket by the derivative of the first bracket. Right, so the first is 5x minus 7y, the first by the derivative of the second bracket. Right, with respect to x, there is no x there. Only x is in the 4x, derivative of that is a 4. Plus the second by the derivative of the first. The second bracket was 4x plus 2y by the derivative of the first, right? Looking over at that first there, no x there, just left with a 5x. The derivative of that is a 5. Start the whole thing, there you go, simple as that. Start the whole thing all over again for the y. Del z del y equals, start the whole thing again, first by derivative of second plus second by the derivative of the first. Right, so again, like the top and the bottom business, the first, when I say first and second, they don't change. The only thing that'll change from the previous answer is the derivative, them second brackets with the derivatives in them. Right, so still the first by the derivative of the second. Right, so the second, there's the second with respect to y this time, not x. So in that expression, there is no y there, there is a y there, and its derivative is 2. Okay, plus the second, 4x plus 2y, by the derivative of the first. So again, there's my first, no y there, there is a y over here, minus 7y, the derivative of that, I'm left with a minus 7. So I pop him in there. Minus 7. Got the colours wrong there, but anyway, it doesn't matter. Right, leave it at that, it's fine. Finally, this chain rule question. I'll just take it down one more time again. There we go. Right. Okay, so if you want to write down the structure, I mean, there is it's only them 5 structures in this course. There are other ones in the logs tables, but we never kind of got to them. There's tan and other trig functions. But as far as you're concerned, you can just worry yourself about the 5 functions: e, sine, cos, ln, and the power function. Right, and get that little diagram right, that the so and write down the box business. Right, so I know that the ln, I'm thinking, this is a thought, you can think this, so the ln of box. Right, if the box, you ignore the box, you deal with it later. If the box was x, the log table says it's 1 over x, or in other words, it's 1 over the box. Then open up a bracket and differentiate the box here. Differentiate box. Bad writing, but anyway, differentiate box here. That's the way the chain rule goes for that function there. Right, okay, so I'll do that over here. So del z, del x. Again, what's my box here? My box is the x squared minus y cubed, ln of box. It's not ln of x multiplied by that there. It's ln of that thing, right? So I'll have, so if ln of box is 1 over the box, or in other words, what is in the box? It's that x squared. We'll even just to highlight it's 1 over x squared minus y cubed by the derivative of the box in here. Right, I'm differentiating with respect to x, so that becomes a 2x there. There is no x that time, so it's just simply 2x in the bracket there, 2x. Okay, I exaggerated the size of that. If you just want to confirm, I mean, I'm happy. It's fine for the minute. We kind of overwrote. We kind of made a big jumbo bracket there. We didn't really need that. I'll just move it over. Anyway, that's not the end of the world. Right, the next time, differentiate this with respect to y now again. So again, it's still the chain rule. It'll still go the same way. What's in the box is still in the box. You don't worry about. It's the derivative of the box that's where it'll look different. Okay, the box is still x squared minus y cubed when I differentiate with respect to y, so it's still 1 over the box because it's ln. Yeah, I think we get that. X squared minus y cubed, 1 over the box by the derivative of the box. Differentiate with respect to y this time, and again, well, I shouldn't look up there. I'll go back up to my original box. There we go. Right, no y there. But there is a y there, and I'll get a minus 3y cubed. Minus 3y squared. Because the power comes down, there's a minus in front of it. Another little thought here. Minus y cubed. Okay, to differentiate that, the power 3 comes down, but there's a minus there to meet it. So there it is coming down. And take 1 off the power. 3 minus 1 is 2. So that's why I get minus 3. Again, that's just a little thought at the side. You don't have to take that. You don't have to worry about that in your answer. Minus 3y squared over there. Right. Is that it for this video? Yeah, that's all them done. Okay. Thank you. Now